post this one output class. So we are going to talk about today we are going to learn the common input and output to the cars, understand the trade-off involved in choosing the input and output to the cars, and learn the difference between the staking and sorting. So actually, all these things, the Brown has done this for us. So in our lab, in our PLC labs, I only taught you on how to wear them. So Frank copied and has done a good job, and he has finished wearing everything for us. So the typical input symbols. So you hear this one is useful for you guys. Okay? If you want to, if you will have a chance to do some projects in your permanent position. So they are typical input symbols. Whenever you see these symbols, and you should know what they are. I'm going to talk about this one a little bit. So this is the limit switch. The NO. NO stands for what, guys? Huh?
Say NO.
Yeah, NO.
NO.
Normally open. Okay, normally open. So temperature switch and flow switch. There's a flow switch. On float or level switch, you can see there is a floater. So pressure or vacuum switch. So this is a food switch, and you can use your food to turn it on or turn it off. So push button. So we are familiar with this one, the double contact push button. So you can click on this one. This is double. This is one, and this is the second one, and then put it together. And two position selector switch. So this is a E. So why this is called E? If you tilt your head, and this guy looks like a capital E. But here is one stroke. These two strokes are very short. It's a bigger E. Okay. So E emergency, the stop switch or the mushroom head. This is normally closed. Normally closed. Okay. Normally closed. When you push it, it becomes open. Open means what? And you just shut off all the circuit. You understand, guys? So what you want to know is a proximate switch. This is our old friend. Emergency, a limit switch. So this is we have already learned that this is symbols. Questions regarding this slide? Okay. So by the way, guys, I'm very heavy. Almost all students are here. But that's the reason we had this is a fall break, right? Fall break, and you guys rest, recover. Now you are more energetic. So this is a typical input, and here is a typical output. And typical output we have. So this is a pattern light. We have 3 pattern lights, and even though some stations some lights went bad. So this is a motor. We can see this is motor, and CR is a control relay. This is a solenoid coil. Whenever you see this sign, it means the solenoid. So this is warning horn, and we do not have warning horn. And this is warning bell. So the last one is warning buzzer. And we do not have these 3, but we know the pilot light. We have 3 pilot lights. We have solenoid, and we have control relay. Also motor. Questions regarding this slide? Oh yeah.
These supposed to be on like the ladder diagrams. Is that where you would see a lot?
No ladder diagram. Ladder diagram is PLC. So this one will be shown on this schematic. It's schematic if you are working with other team members, okay? And to enhance the readability of the diagram, and they just put this here. Right? So the input cards. So we have 2 input cards. We have 2 cards. One is input, one is output. For the input cards, so we use the 1224 VDC. So this is what from Coffee has done for us. But when you guys start from scratch to build a PLC system, and you need to select your own input cards. So this is a typical voltage for input cards, roughly in order of popularity. So this one is the most popular one. which we are using now, the VDC. So 100 to 120 VAC. So this is a VDC, AC, DC, 5 VDC. This is a TTL. So this one, so when I was a student, that's 30 years ago, and we mainly use the TTL. So this is TTL. This is the voltage level 5 volts. So we have 200 to 24 to 240 VAC and 48 to 24. So PLC input cards rarely supply power. Okay, that means you need to have an external power supply and to supply power for the inputs and the sensors. So keep this in mind. Questions regarding this input card? So I'm showing you now, so you have some idea. When you ask to start building a PLC system from scratch, and you can use this one, okay, as a guideline to select the input card. So this is typical. I'm going to show you a typical AC input card. Typical AC input card. So this is external one, as I said. So input card does not have this is power supply. You should have an external power supply to supply power for all these 16 bits, the output, these input terminals. So we have so these switches, we have these push buttons. So with AC common and AC common. Okay, so and then we have this one. Can somebody tell me what this one is? What is one? Opto isolation, right? You forget everything else? This opto isolation, you can see this is the in and this is the common. So here is this is a diode. Okay, so this diode can only allow the current to flow from top to the bottom. And here is opto isolation. And because usually this external power is much higher than the power driving the CPU, which is usually 24 volts. So we should have opto isolation. So this opto isolation means that this diode will emit the light. So this light will drive. This is a CPU. Will send a signal to CPU. Instant that this guy and this guy connect together. This is called opto isolation. You should write down that. Okay? Opto isolation separates the external high power from this internal low power to protect the CPU. So
you mentioned that one more time.
So opto isolation is used and to protect this is external high power to protect the CPU, which is usually driven by low power, to separate the high power from this low power. So these circuits, they are not physically connected, and they are connected using the light. Opto, we have this is opto isolation. This kind of things is called opto coupler. Right? Opto coupler. Couple them together using light. Questions? Question, and move on to the next one. So this is a DC. So this is AC input. So we have a DC input module, and this is switching. So here, this one is from in and to the common. So here is also this is one direction. So this here, the whole thing here, okay, the whole thing is called opto coupler. Opto coupler. The whole thing. The whole thing, guys. So this and this is one thing. Is one device. Its name is called opto coupler. Opto coupler. COUPLER. Coupler means that you connect two things together. Opto coupler means that you connect these two guys together using the light. So here is how to connect to the 24 VDC as the input module. So here is the input module sourcing. You can imagine how this is thinking is different from sourcing. Okay, and thinking the this you can just think the current or this is the water drink stick from top to the bottom. But this is sourcing, and sourcing is only in another direction. So this is also after isolation, after coupler. So this is called sourcing. So thinking and sourcing, and we have learned this NPN and the PNP, these are transistors. Thinking or NPN, see what is thinking, and this is a this is thinking, so this is a sourcing. So, and thinking when active, output allows the current to flow and to a common ground. So this is thinking. When active, when this is open, and so the output allows the current to go flow to a common ground. This is thinking. And provide greater flexibility as different voltage can be supported. So sourcing is the PNP, usually connected to the PNP here. Alright, so this is sourcing. I'm sorry, this is the sourcing. When active, current flow from a supply through the PLC and to the ground. Most suitable only when all the devices are used a single supply voltage, are more popular than staking. So this is one is staking, one is sourcing. So this is a sourcing. Right? So this is a sourcing, and this is a staking. So common, what is common? We have seen the common, right? On this PLC board. The common is a reference that determines the OV, the zero voltage. All other voltages are measured relative to it. Is common. So if there is a second, the power supply connects the neutral so that both naturals would be connected to the same common. So do not confuse common with ground. Okay. So our VDC and our VD minus, positive negative VD minus is connected to the common, output to the common. Okay, so they are the same thing. Common is a reference, not a data voltage. The ground prevents shocks and damages to equipment. When current flows to the ground, it is bad. So the ground, and sometimes we call the minus is a ground, but it is scientifically it is not straight. It should be called VD minus or this is common. You understand, guys? Sometimes some people call it ground, but we know what this guy is talking about. But scientifically, that is not straight. To be straight, that one is called common. Okay? When you have multiple power supplies, this is the minus of each of these power supply must be connected together to make sure you have the same reference point. You understand? So I'm talking about VDC, not VAC. AVC is not. It's not. So trade-off in choosing input card. So whether I should choose DC or AC. So there are something you need to consider. So DC input. Usually low voltage and therefore safe. DC is safe. Okay. Very fast AC inputs require longer on time. For example, a 60 Hz wave may require up to 1/60 second for reasonable recognition. So AC is slower. And so the larger variety of electrical system can be connected because DC these devices are more popular. So AC input sometimes we need to use AC input if if we need more need it to be more immune to noise, so they are suited to long distance and noisy magnetic environments. The AC is much better in this regard. Right? So AC power is easier and less expensive to supply to equipment. Much cheaper. So AC signals are very common in many existing automation devices. Questions regarding this one? When you select either DC or AC, and you need to think about your needs and you think about your budget.
It's the one that shape one.
Shape one, but also it needs to, it should be able to satisfy your needs, right? So then we talk about output cards. The output cards we have, so this is, we also arrange this in order, and this is the highest one is the high popularity. 120 BAC is most popular one. You guys know why? Because 120 BAC is the postcode reporting in the US, right? So that's reason this one is most popular one. 120 VAC, 24 VDC, and this is a 230 VAC. So this 230 VAC, usually this is a heavy duty device. For example, the water, dryer, and this refrigerator, they are driven using this one. But for commonly used ones, and usually use 110 or 120 VAC. Okay, guys? If some guy want to argue with me, IEUS is 110 is a common one. Yeah. 120, 110 is we're talking about the same thing. But they are not exactly 110, they are not exactly 120. That's the reason there is some little argument say 120, 110, they are same, talking about the same. Question so far? No question? So this is the switch outputs, transistor or track outputs. If you use transistor or track, so response time is well under 1 microsecond, so this is very short. Transistors, NPN and PNP limited to DC outputs. Track actually I show you guys track is a combination of these two diodes. So that means that these tracks and they can be used for AC, two directions. Okay? So one diode only allows us to have current in one direction, but the tracks they are a combination of two diodes. Oppositely. That's the reason. So AC you can just use tracks for AC. So well suited for devices requiring less than 1A. So 1A is very high. I told you guys 1A this is electricity, the current can kill everybody instantly. Hunting, if you want to hunt some very big animal, and you use this one, and then that you can accomplish very another aspect. I mean, it's very dangerous ones. 1A is very dangerous level for all living animals. No.
It's like do people get a plan for
A4, it will burn into ashes instantly. No time for okay. So this is not this is from the scientific reading. Okay. So the typical AC output model, and I think this output model, and you can see here I also have this is AC, okay, from the this is from the CPU. So this is from the output, these actuators. So here as is also I have opto isolation. So here, so to protect the CPU. So we have CR. CR is the control relay. Okay, control relay. And so these they are 4 lights. Questions? So whenever you see there is a question, whenever you see and how we protect the CPU in our PLC, you need to come here, okay? And show me the keyword is that we use opto isolators to protect the PLC from externally high voltage. So the DC output module seeking, and also here this is DC. So by the way, guys, this is a track. Okay, so this is a track, and we have two. This is the diodes combined together. So this is one diode. This is for DC, and because the current only goes in one direction, and so also the opto isolation. Opto isolation. So if I have signal here, so this signal will be conveyed to the output actuator using light instead of physically together. If we're physically together, if something happens, if we have this voltage disruption from outside, and then this voltage disruption will go to the CPU immediately and burn it. Right?
It's still off topic, Dr. Mo, but where do you find the video recordings for these videos?
Video recording?
Yeah, like all the classes.
Yeah, I'm recording.
I know, but where do you like find them to go back to rewatch them? This Google Drive. The Google Drive.
Google Drive.
Okay, thank you.
Yeah, Google Drive. Because the canvas does not allow me to do that because it's usually very, very few. So the input vary. So we have done this, and I'm going to show you guys. So actually, the Ram has done this one for us. So this input 24 AC input card. So it is a 24 VAC power supply. So this is the normally open push button. It's normally open temperature switch. Is common, and you just put them together. So here is a button. Here is a button. Here is the switch. So when you write these using our PLC diagram, it is this push button, and this is a temperature sensor. So here is address. So this you can see. So this push button here, is connected to 01. So this is 01. So this one is connected to 03. So this is 03. What is this I? So this I is this one is the slot. Okay. Which slot? This is slot in rack 1 over 3. Rack 1 over 3. So this the whole thing. This one plus this is the exact bit of the push button. You understand, guys? Now also I want to emphasize when we use the PLC, make sure you connect all the input and to the PLC, all the output to the PLC also. And you should not put input and output together. You should not wear them together. You understand? Because on how the PLC is just as a CPU, and PLC just like a brain, our brain. So we have the inputs to get the information from outside, outputs and to take actions, do something. Okay? So you cannot connect the inputs and to the outputs directly. You should connect the inputs and with the CPU, the outputs with the CPU also. So this is different from a hardware variant of the system. For our first lab, I taught you on how to hardware on this system, right? So you need to connect hardware, the bit by bit, terminal by terminal by terminal. But for the PLC, you need to connect all the inputs to the PLC. And for the outputs, you need to connect all the outputs to the PLC. You should never ever connect the inputs and outputs together when we use PLC. This is very, very important. So this is a note. The inputs are normally high impedance. This means that they will use very little current. So the resistance is high. So the output variant, and so suppose this is our output card, and so this we have suppose we have two outputs. The one here is positive. This is a 03 and this is 07. And for here, the relay is connected to this 3, and then we connect to this motor. Okay, so this one is very similar to the circuit we use and to drive our fan. Right, our fan is driven by, and this is a VAC 120 VAC. You guys still remember that? And I will ask you, and how can we drive a VAC? How can we drive a fan, and who is usually driven by VAC, and using PLC, and who is usually output the VDC? I'm going to test you this understanding of this question. You should answer first. I use a PLC to control one relay. Then this relay is connected to the fan. Okay? I control the relay, and the relay control the fan. So by using these two steps, this is controlling this is a scheme. I can control I can control a fan by PLC. So you need to know that, right? Okay. So these are very similar to what to our fan system. So this here is a lamp. So we have a lamp here. So this is a lamp is connected to the power supply, and another terminal connected to this bit. Here also, this relay is one end of relay is connected to 24 bits, 24 VDC power supply. So if this is our hardware, okay. So you need to wear it in your hands. So if we want to write this one after you finish wearing, if we want to write this in the PLC diagram, and you should have this. This is a motor, this lamp. Motor is address. Address is 0012 rack 1 pin 2. Which bit? 03. Right? So this is my motor. Even though I write the motor here, but actually I control the bit 3, and then using the bit 3 to control the relay, and then using this relay, I control the motor. So this is a bit 3. For the lamp, this lamp, lamp is connected to bit 7. So the address of the lamp is bit 7. Questions regarding this?
How come the lamp feeds power from the 24-volt DC? Doesn't the output supply power?
You already know, but for our it is. For our the hardware using it is. But here no. Well, that's a good question. Let me repeat. And for our input cards and output cards, and from the coffee has bought a very good 2 cards, right? And they are connected to the PLC, the power supply. You understand? They are connected to the PLC power supply. But still, we can treat that one as this is our external VDC, but we cannot visually see them. You understand that? And on the back of the rack, and it is connected this way. That's a good question. As I said, from Kobe has done this one for us. If we want to do this one start from scratch, you need to do it. You need to buy a 24 VDC or use the same power supply for the PLC, and then just connect to the input card. So Farmer has done this for us, right? We are standing on the front story. You understand? So otherwise, you need to hardware them together. Questions? Question? So the output wearing, so this is another one. So this is a VAC. So this is a VDC. So here is a VAC output. And VAC output, I have, this is the VAC output here. So this is, suppose this is a relay, okay? This is a relay. I control this relay, and also this relay controls, this is a motor. So this is a 24 VDC power supply here. So here is a lamp. Here is, so this is a 120 VAC power supply. So this one is for the motor. This one is for the motor. So this is only for the motor. So here address is 3, and so here is address is 7. bit 3 and bit 7. So here this 24 volts output card. To the power supply, we have power supply. We have this is a relay, this motor, and this lamp. So this is 3 and this is 7. Questions regarding this one? The seeking sensor. So it's called seeking and this is sourcing. On seeking sensor, so this is a physical phenomena, okay, physical for phenomena, and this one is captured, and this is go to the sensor detector. So here it is feed as on this one. So this is the NPN. So this is a base, and this is a base. Okay, so this is a physical phenomena. Phenomena is connected to the base terminal of this NPN. So here is current flow. Current flows in when a switch is on. If this one is turned on, the current can go this way. So you still remember how the NPN works, right? How the NPN works? If the different voltage difference between the base terminal and this terminal is higher than the threshold value, usually 6 volts. And so this one will be turned on. Turned on means that the current is allowed to flow from this terminal to this terminal. This is what I propose. However, if the voltage difference between this base terminal and this terminal is less than threshold value, and so this one is turned off. Turned off means that the current cannot go away, cannot go flow within this NPN. Sounds good? So if I detect if there's a flow or not, then I know the physical phenomenon. The physical is a sense signals. So the sorting the sensor you can hear. The sorting sensor need use the PNP. So this is the PNP, this is the base. For the PNP, and we also for the PNP, and how the PNP works, guys? How PNP works, the voltage difference between the base terminal and this terminal, it is if the less higher than the voltage, higher than the threshold voltage, and we have the current flowing, and this is the PNP. Otherwise, if the voltage difference between the base terminal and this terminal is less than threshold value, no current. Okay, you can see the difference here. It's just like you taking a shower, and this is sourcing, and the water going down, right? Here, just like you are just washing dishes, and washing the dishes, and you just open the valve, and so the used water just go down to the soil. One is a staking, one is a sourcing. It is very, very intuitive for me. Did I make sense, guys? Okay. So staking sensors will connect to ground or pull the input low when actuated. Think about the NPN. The sorting sensor will connect to the voltage, this voltage, or pull the input high when actuated. So if I ask you guys, what is the difference between these staking and sorting sensors? And tell me this. You understand? Sorting, just you think about you are taking a shower, you just open it, the water coming down, right? Sorting. And staking, just think about that you are washing dishes, and you just open the valve in the sink and let all used water go away, go to the soil. So this is staking. Sourcing from the top to yourself. Staking is from you and to the soil. Understand? So this is how I remember these two guys when I was a student. If I connect this new knowledge to my daily experience, and I can remember this new knowledge permanently. Questions so far? No question? No questions? Here are the symbols. NPN seeking and PNP. When we talk about NPN, we are talking about seeking. When we talk about PNP, we are talking about sourcing. So this is how we connect it. NPN, blue, brown. So these are the three colors for the terminals. And I cannot remember this one. Okay, so if you have by the NPN sensors, you need to come back here and to see how you are going to wear it, or just use the info provided by the manufacturers. I cannot remember, but I know what is the NPN means and what the PNP means. Then I come back here and to connect them correctly. So here is the connection of the output device. So here is the sensor, and here is the sensor, NPN, PNP. So this is sourcing, and for this seeking, and how to connect these sensors and these two sensors. The PLC connection. So this is a PLC card. Okay, PLC input card for seeking sensor. This is for seeking sensor. So we have NPN sensor. So we have voltage. We have this is connected to this speed. So this is a positive V. And so if this NPN is turned on, and the current can go through this way. So here is opto isolator. Okay. So opto isolator is a whole thing. When you compare the device, it's called opto isolator, and this is this have several terminals, and you can connect this opto isolator. So this is the whole thing, and it's physically one device. So this is a seeking sensor. For this sourcing sensor, power supply is a PNP, and this is a positive V here, positive V. So if this is if this is a base, if the voltage difference between the base and the positive V is bigger than the threshold value, and we have current. This is current. Once again, this is opto isolate.